Good afternoon, everyone. Myself, Akash Venkatesan. Today, I will be explaining my fog and edge computing project, which is simulation of multi-tier task offloading in edge fog cloud computing environments. So, basically, in modern IoT applications like healthcare monitoring, smart cities, and disaster management, it requires real-time processing of data from distributed devices. So, if all these data is being sent to the cloud, network congestion might happen, and there is a high chance of latency issues. So, a proper solution for these issues is a multi-tier processing approach using edge, fog, and cloud layers to manage tasks based on their size and urgency. So, basically, this project is inspired from the paper Task Offloading for Post-Disaster Rescue in UAV networks, where different computing layers share the workloads for faster and more efficient processing. This is the architecture diagram of the project. If you see the box highlighted in green, which is the edge node, which calculates which simulates the tasks, and based on the MIPS value, if the task has less MIPS value, it is being processed at the edge node. Otherwise, the medium level tasks are being forwarded to the fog node, and the large tasks are being forwarded to the cloud node, which is hosted on EC2. And all the three tiers will store their results in the Amazon S3. And basically, our project has implemented a three tier architecture. The first is the edge node, which generates which simulates tasks with random computational loads based on the MIPS values. So, like MIPS is nothing but a million instructions per second. It is but nothing but a way of measuring the computing power of a device, like how much computing can be done in per second. So, based on this MIPS value, the task distribution is done. So, if the task is small, it can be processed at the edge node, and if the task is at a medium level, then those tasks will be forwarded to the fog server via the HTTP post request. And in the fog node, the tasks which are being sent from the edge are received here, and the medium level tasks are processed here. So if the task is even more large, it is sent to the cloud layer. It also acts as a relay between relay to upload the metrics.csv to the cloud. Like all the metrics, or every performance metrics of all the tasks are being stored to the cloud. So cloud in the next is the cloud server, which is hosted on EC2. It is used for processing heavy tasks. The tasks which are larger to be processed in fog node, those are being processed here. And here also the metrics are being stored in Amazon S3 for data persistence and encryption. And we have used Flask framework. It is used to create a lightweight REST APIs for the communication purpose between H, fog, and cloud layers. So, and also we have used Amazon S3 for storing all the tasks output and performance metrics, which acts like a centralized storage in our project. So basically, we have simulated 30 tasks with different MIPS loads to test the routing logics. The routing logic will be nothing but if the task is small, it will be processed at the edge. And if the task has a higher MIPS value than the capacity of edge, it will be processed at the fog. And if the MIPS value is even more large, then it will be offloaded to the cloud. So when it comes to performance metrics, for each of the tasks, the performance is being the latency is being recorded from end to end, and all the results are being saved in the metrics.csv file, and it is uploaded to the S3. So once after executing the program, we have observed the results as follows. If the MIPS value is low for a task, then those are tasks are being processed at the edge node at a faster pace. And if the MIPS value is a little bit higher at a medium level, then those are processed at the fog node, and the latency is at a balanced level. And if the MIPS value is very high, then those tasks are being processed with the cloud, and also with a stable upload time to S3. So now we will see the demo of the project. So basically, this is the code for each client. So here the libraries are being imported. For instance, time library is used for latency measurement and delays, and random library for generating random MIPS values for tasks. Similar to that, each of the libraries are imported. And next here, the MIPS capacity of the edge node is mentioned here, which is 800. So if the MIPS value crosses this, then those tasks will be offloaded to the fog server. So totally 30 tasks we are generating. So this is the task generation process, and in the MIPS values are randomly assigned between 300 to 700 for a task. And for task processing decision, like if the MIPS value is less than 80 percentage, edge processing capacity, then those tasks are processed here, or it is being sent to the fog layer using the HTTP post request, which you can see here. Here also the CSV metrics is being generated. And if we go to the fog server, we can see the same libraries are being imported, and also the fog layer capacity, the MIPS is mentioned here. Here again, the processing is done. So if the MIPS value is less than or equal to the fog's speed, it processes it locally. Or if the task is too large, it forwards to the cloud server for processing, and then it returns to the edge client. So here also the metrics are being generated and it's stored to the S3. So now I will show you the code of the cloud server. This is the code of the cloud server. So basically that, I mean, tasks which have more MIPS values are being processed here. So now I will execute, now I will start this server, cloud server. So now the cloud server is running, and this is the fog server. I will start this as well. So now both the fog server and cloud server are running. Now I will execute the fog client code. So if you see here, the tasks are being generated and it is being processed at edge, or else it is forwarded to fog or cloud based on the MIPS value. So yeah, all the 30 tasks are being processed. If you can see here, for instance, if a task has less MIPS value, it is processed locally. If the task has even more MIPS value, it is sent to fog, or else it is sent to the cloud. And also the metrics are saved to the S3. So this is the fog side output. So if the task MIPS value is capable, fog is able to do that, then it is processed locally. Otherwise, it is again sent to the cloud. So now I will see the cloud side output. So this is the cloud side output. So all the tasks which has high MIPS values are being processed here, and the outputs are being stored to the S3. So basically, this is the S3 bucket where all the metrics and tasks JSON files are being stored here. So yeah, uh, that's it for the presentation. Thank you so much for your time. Thank you.